Hey y'all, welcome to Tutor Bros, and in this video we're going to be talking about areas and perimeter of shapes. So I want to give you all a quick description and get you all to better understand what area is, and I want to go ahead and talk to you about what perimeter is also. So you may know or you may not know, so this just may be a refresher for you all, or it could be something new to learn, so let me try to explain it. So when we're working with area, whether we're looking at, let me draw a better shape for you. Whether we're working with a rectangle, triangle, circle, heck, even something like this. When we're talking about area, we're looking at the insides of these shapes. So we want to look at the insides of the shape because area tells us how much lies inside of it. And you can always tell by what type of formula we're working with. Normally when we're working with area, they're going to be multiplying. So what they're trying to say is how many rows are in here by how many rows are in here, and that tells me how many pieces are in there left, or how much space there is to put inside of there. So the way I like to think about it is like a parking lot for a car. So here we have those two lines. It's how can I fit a car in there? Can I go ahead and fit something inside of here? The answer may be yes, the answer may be no, but that's how we figure out what we can place inside of that specifically. So that turns out to be area. It's whatever's inside of this shape. We can even calculate certain shapes, and we'll talk about that. You can calculate area of different polygons is really the statement I want to say, and we can do that, but we'll go ahead and explain that in another video. Now, when we're dealing with perimeter now, there's going to be two talks about it now. So when I'm dealing with perimeter, there's a certain rules for depending on the shape. Now, just like area, the rules depend on the shape also, but we can generally classify them into two different things. So when we're working with polygons, or right here, these certain shapes like squares, triangles, rectangles, trapezoids, they all have a very similar formula. Now in a later video, I'll go ahead and explain it based off of like a rectangle. Now, but I'll just give you all the ideas first. So in this perimeter, what we're going to be looking at, perimeter is the outside. It's how much fencing can you put up to close in your dog, or how much fencing it takes to put it up in a yard. So a lot of the idea when it comes to perimeter is how much space or how much do I have on the outside? How long does it take me to walk around my block to get back to my house? Now, that could be a form of perimeter because I can count how many steps it takes around, so I can figure out how long it is using perimeter. Remember, perimeter area, we could talk about it in form of distance also, but I won't get into that now. But overall, that's just kind of the way this works. But like I said, depending on the shape we work with, we'll be working with different formulas. And you can check out like my other videos, and you'll see that I'll list out the formulas based off of what we work with. So depending on what the shape is, we'll look at it. So here in this video, we're going to be focusing on this specific problem is on a polygon. It's given us a random shape, and we're going to have to kind of work with it. So depending on how we want to work with it, we can look at it to calculate the perimeter and area. So in order to calculate perimeter, especially for something like this, you want to add up all the sides. You want to add up all the sides. Now, you may be thinking, oh, this may be straightforward, which hopefully you are thinking that, but in case you aren't, we can talk about the shape itself. So I'm going to kind of draw it and label it out. So then we have 8 meters, 5 meters, 3 meters, and 11 meters. And watch out with y'all, just to let y'all know, sometimes they try to trick you by changing the units from meters, so like feet or whatever, so depending on what. So a lot of this math I'm going to be doing will be on my calculator, so just heads up on that. Alright, so for some of y'all that aren't seeing this, or maybe you notice that, hey, we're missing some sides, or maybe you didn't notice we're missing some sides, but in this one, you got to notice that we're missing some information off of this, because in order to do this, you have to be able to count, or you have to be able to figure out how far or how much a certain length is what I would say. So assuming that I start off here, and I start walking my path, I notice, oh, okay, well, this is 8 meters, so I jotted it down. So I'm like, okay, I go down, go around a block again, that turns out to be 5 meters. But then when I head down this street, hold up, We don't know how far that is though. Then I go and then I take this down, go down an alleyway, trying to cut across the street or however you want to see it. And then I say, oh, I didn't remember that distance either. But then I started recounting. I said, oh, okay, this is 3 meters. Gotcha. Then to get all the way back home, I was 11 meters. So the kind of the idea of perimeter is like, okay, how far did I walk around, or how much fencing can I put around this? Well, I'm missing. I didn't count to the sides for my fencing. So here we can kind of work at and see what we're missing. So the way that I like to think about this is grab sides and measure them with what we already know. So just as an example here, we know that this length here is 8 meters. And we know up to this point here is 3 meters. So if I want to say this and this will be the same 3 meters, which means that this piece to this piece will also be the same distance. So we can use that kind of idea. It's not really proportions, it's just kind of using the sides of walls and what we can use. So we'll say 8 minus 3, which tells us if this is 5 now, then this side is 5. And we'll go ahead and find the missing one using the same idea, but now instead of using this wall, or the outside wall, that 3 wall, I'm going to be using the 11 to help me calculate what's going on with the 5 up there on top. So then we'll say 11 minus 5 gives us 6, which means that if there from 5 is up to this line here, then if I put it in a little barrier, we can see that, oh, this missing piece is 6 meters. So then we notice that this piece over here is 6 meters. So in order to calculate that, you just add up the 8 plus the 5 plus the other 5 plus the 6 plus the 3 plus the 11, which turns out to be 38. And then as you can see in the little box up there, the perimeter, it turns out to be 38. So the perimeter is 38 meters. Remember, it's a single meter because it's not squared. We're not multiplying. So now we're going to be looking at the area now. The area is a little trickier, but it could still be done. So with this, we're going to kind of look at the same idea. We're going to have a shape here. So here's the idea of the shape, but now we know all the information. We may not need all the other information, but I'm glad I have it though. 5, 5, 6, 3, and 11. All right. So you can break this up however you feel. So I'm going to kind of show you the ways that you could break it up. One way would be by breaking it up here. And we notice that we can use this as one piece, and then we can use the other piece here. Now, when you calculate areas of a polygon or a shape, you want to go ahead, and if there's multiple shapes that you break it into, you just want to add it up together. So that'd be one way that you can look at it. Another way that you can go ahead and look at it would be like this. Now, there's plenty of ways. I'm pretty sure y'all are creative enough to find a method that works for you. It might be even better than mine. So go ahead and let me know in a comment some details, what you all think may work better for you. So here's another way of looking at it. So some people think, oh, okay, this might work better. So, depending on what they think. But it's really the same idea. So as you can see here, we're dealing with 2 rectangles essentially. So remember, for area of a rectangle, just to let you all know, area of a rectangle, we do length times width. It'd be very similar to a square. I'll get into that later. I'll move this one down. So what we're going to go ahead and do now is we're going to go ahead and calculate the area. So what we'll see here now is, when we're calculating area, I'm going to break up my shapes. I'm going to be using this one. I'm going to call this one 1. I'm going to call this one 2. I'm going to use number 1 to help me calculate it. So we notice that if this up here is 5 and this is 5 here, so that's pretty much like length times width. So that covers 5 and 5 there. So we're actually pretty okay with that because we already know the specific points based off of the information that we calculated earlier. So now on this one here, on the bigger piece, well, we know that if this is length, this is width, then we can say, well, hey, the length here could be 3, and then the width could be 11. I may have them backwards. Let me know. I'm pretty sure I do have them backwards, but I'm just going to run with it now for time. So So what we're going to do is area will be equal to length times width, which would be 5 times 5, which is equal to 25. Then we'll say for this bottom one, length times width. Remember, always write the formula. Even if you can't save time, write it out. We'll say 3 times 11, which gives us 33. Now, in order to figure this, I'm going to call this area rectangle 1, rectangle 2. So in order to do this, area is equal to area rectangle 1 plus area rectangle 2. So then area is equal to 25 plus 33. Remember, you're just trying to break up the shades and just squish them together. So whichever way it works best for you, it's going to work. So area is equal to 58. And then now we're going to say meters squared. Remember, anytime you do area is always squared. So that's it on this video. On some later videos, we'll go ahead and see some more problems on areas and perimeters of shape. So let me know any comments or descriptions. Thanks a lot.